Hi everyone, welcome back. On Wednesday, you reviewed how to convert back and forth between moles and grams, something that we learned earlier in the year. And yesterday, we talked about what stoichiometry is and how to compare the amounts of reactants and products in a chemical reaction by using that mole ratio. Today, what we're going to do is we're going to put those two pieces together and talk about how we do stoichiometry with problems including mass. The reason why this is important is because we can't measure moles directly. So you can't go into a lab and pull out a bottle of a chemical and just scoop out a mole of it, right? What we can do is we can go into the lab and put something on a balance and measure the mass, right? So the way that we are able to measure reactants and products is by their masses. And then we can connect the mass and the moles using the molar mass. Right, so we can go back and forth between grams and moles anytime we want, as long as we know the molar mass of our compound. So when we do stoichiometry problems involving mass, those are going to involve 3 steps. And it's, like I said, putting together the pieces that you did on Wednesday and Thursday. So step 1 is to convert the mass of substance A, whatever it is that you're starting with, to moles of A using the molar mass. Next, you're going to use that mole ratio that we talked about yesterday with the balanced equation to convert moles of substance A to moles of substance B. And then finally, you're going to take your moles of substance B and convert it back to grams, again using the molar mass. So we're going to use dimensional analysis again to complete each of these problems, but now they're going to have 3 steps. So before we get into talking about the chemical reactions, I want to go back to my grilled cheese analogy. So yesterday I said I wanted to make a grilled cheese sandwich. Today I want to open a grilled cheese restaurant. So the thing about opening a restaurant is that I have to order supplies and I have to order them by weight. All right, so I can't call up a supplier and say that I need 14 slices of bread. I need to buy a certain weight of bread. So first let's look again at our recipe, our chemical reaction here for the grilled cheese. So remember that I'm going to need bread, and I'm going to need cheese. I'm going to put those together to make my sandwich. And then also remember that I'm going to need 2 pieces of bread and 1 piece of cheese to make 1 sandwich. All right, so if I want to order supplies for this grilled cheese restaurant that I'm opening, I might want to think about what I have and what I need. So let's say I go to my fridge and I'm pretty well stocked, and I find out that I've got 11 pounds of American cheese in stock. So I need to know how many pounds of bread I'm going to need to buy. All right, so the first thing that I'm going to need to know in order to do this is how much does 1 slice of cheese and 1 slice of bread weigh? Okay, and so 1 slice of cheese has a weight of 0.125 pounds, and 1 slice of bread has a weight of 0.100 pounds. So this information is going to allow me to convert from my mass into my units of slices here. Now I want to set up my dimensional analysis problem. This one's going to have 3 steps, so I want 4 sets of boxes, 1 for my initial information and 3 for the conversion factors that I'm going to need. So remember that I always want to put the amount that I'm starting with in the top left-hand corner. So I'm going to put 11 pounds of cheese in that top corner. Oops, I forgot my 0.0 here, but there should be a 0.0. And then underneath that, I'm going to put a 1 to remind myself not to put anything else there. Now in my next set of boxes, I want my first conversion factor. All right, so if I want to compare cheese to bread, I can only compare them by the number of slices. I can't compare them to the number of pounds. All right, so first I want to know 11 pounds of cheese, how many slices of cheese that is. So I can use the information that I gave you on the last slide. So for each 1 slice of cheese, the weight is going to be 0.125 pounds. I want to put pounds down here on the bottom so that the units cancel. All right, now I know how many slices of cheese that I need. All right, I also know from my balanced equation that the ratio of cheese to bread is 2 to 1. So I'm going to put 1 slice of cheese on the bottom and 2 slices of bread on the top. Now I can cancel out my units of slices of cheese, telling me how many slices of bread I'm going to need. Now, lastly, in my question I said how many pounds of bread do I need to buy? So I don't need to know how many slices. I need to know how much those slices weigh. So I want to use the weight, again, of an individual slice of bread. Now I'm going to put slices of bread on the bottom so that the units cancel, and 0.125 0.100 pounds on the top because that's my pounds per slice. Now slices of bread will cancel, leaving me with the unit of pounds per bread. So I followed these 3 steps of converting from mass to slices, using my ratio from my balanced equation, and then using the mass again per slice of bread here. I'm going to multiply everything across the top, so 11 times 2 times 0.100 divided by everything on the bottom, so that would be 0.125. And I'm going to find here that I need to buy 17.6 pounds of bread. I've got 3 sig figs in my question, so I want 3 sig figs in my answer. All right, now let's take a look at an actual chemical reaction, and this is the same one that we looked at yesterday. So again, the synthesis of ammonia from nitrogen and hydrogen gas. I've got here my balanced equation, and remember that 1 molecule of nitrogen reacts with 3 molecules of hydrogen to form 2 molecules of ammonia. Now remember that we can scale that up to moles, and we can say that 1 mole of nitrogen reacts with 3 moles of hydrogen to produce 2 moles of ammonia, and that tells us our mole ratios in this problem. So a question I could answer would be something like this. How many grams of nitrogen will it take to produce 100 grams of ammonia? All right, so if I want to make 100 grams of ammonia, how many grams of nitrogen will I need to include? All right, now the important things that I need to know before I get started on my problem are the molar masses of both ammonia and this nitrogen molecule. And remember that this nitrogen molecule has 2 nitrogen atoms here. So my molar mass of nitrogen is going to be 2 times the individual mass of a nitrogen atom, which is 14 grams per mole. So my molar mass of this nitrogen molecule is 28 grams per mole. So that means 1 mole of nitrogen is equal to 28 grams. So this is what we're going to use as our conversion factor. My molar mass of ammonia is 17 grams per mole. So that's the mass of 1 nitrogen plus the mass of 3 hydrogens. All right, so that means 1 mole of ammonia equals 17 grams. Now I can set up my dimensional analysis problem. And just like the one with the bread, I am going to have one set of boxes for my starting information, and then 3 set of boxes for the 3 conversion factors that I'm going to need. Now I want to start with the information that I'm given in the problem. So I want to make 100 grams of ammonia. I'm going to put that in that top left box over 1, so I remember to not put anything else there. Now step 1 is going to be converting from grams to moles. I can't directly compare grams of ammonia with grams of nitrogen. I can only compare moles to moles using that mole ratio. So my first step is to convert to moles. So on the last slide, we said that the molar mass of ammonia was 17 grams per 1 mole. Now, I want to put grams in the bottom so that I can cancel out units of grams of ammonia. Now I have units of moles of ammonia. Once I'm in units of moles, I know that I can directly compare any 2 substances in my reaction. So I can directly compare the amount of ammonia to the amount of nitrogen. And I can see here that from the balanced equation, it's a 2-to-1 ratio, looking at those coefficients in our balanced equation. So that means for every 2 moles of ammonia that are made, I'm going to need 1 mole of nitrogen gas. Note that I'm using the coefficient here, not the subscript. All right, so the coefficient, when you don't see 1, the coefficient is 1. So that's 1 mole of nitrogen to 2 moles of ammonia. And this allows me to cancel out units of moles of ammonia on the top and the bottom. Now I have units of moles of nitrogen, but the question asks how many grams of nitrogen. So now I've got to do that mole to gram conversion again with nitrogen. On the last slide, we said that the molar mass of nitrogen is 28 grams per mole, so 2 atoms of nitrogen times 14 grams each. Now, because I've got moles on top, I want to put moles on bottom, and I want grams, so I'm going to put grams on top. So I'm going to put that molar mass of nitrogen on the top here. Now, moles of nitrogen cancel on the top and the bottom, leaving me with grams of nitrogen as my only unit. Now that I've got the unit that I want, I'm ready to solve my dimensional analysis problem. So I'm going to multiply everything across the top. That's 100 times 28. And then I'm going to divide by everything on the bottom. So I'm going to divide by 17 times 2, or 34. So when I do this, I get an answer of 82.4 grams of nitrogen, Notice that I've got 3 sig figs in my question here because I've got this decimal point making these zeros significant. So I've got 3 sig figs in my answer here. All right, now I want you to try a couple of these problems on your own. So it's putting together the pieces of converting from grams to moles and then using that mole ratio for stoichiometry.